Jai Shri Manaran kids. Today's class will discuss about the JEE Mains 2026-21 January shift 1. Okay, let me have the brief discussion about the paper analysis. Then we'll go for the physics paper discussion. Hmm. The physics paper, easy as usual, like 2025. How the papers came now. The similar flavor is what the physics. Hmm. And the chemistry, the moderate, and the maths paper, similar to 2025, lengthy and difficult. This for the 21st January shift 1, morning one. Then about the marks, they usually what marks and percentile will get it. So I'll start with the bottom. 92 marks will be around 92 percentile. 2 3 marks will be on either side. I think this is what typical the cutoff marks, which is usually ranges around 90. No, for this paper, those who are writing, no, you can expect this one. And for if you get 100 marks, 94 percentile, 112 marks. So exactly 112 to 3 marks on this side. I'm not the NTA person. I'm just physics teacher and I interacted with chemistry and maths teacher. No, roughly when we shared the ideas, no, this is what the conclusions we have came. So 112 marks will be 95 percentile, and 128 marks is about 96 percentile, and 140 marks is what 98 percentile. This was the threshold everyone we will focus. It is coming. So paper definitely we can say moderate. Overall paper let it be moderate. And for 170 marks, 99 percentile, above lot of variation. We can't go for some 99.5, 99.9. Lot of variations will come from 170 to it may go up to 100%, it may go up to 290 or 300. So very huge data will be there. So typically, this is what most of you will focus, no, around 140 mark. Those who are writing the 22nd, 23rd, 24, no, keep threshold of crossing this 130 marks will be really on safer side for 98 percentile. Then how the physics weightage will focus on the weightage. The physics weightages. Mechanics, they've asked 8 questions. Fine. Next again, the electricity magnetism, 7 questions. Modern physics, 4 questions came, including semiconductors. Thermal physics 2, waves and sound 1, and optics 3. So count it all, 15, 15, 19, 19, 25. Like this is what they have distributed this particular January, 21st January, shift 1. So I will not discuss paper, I discuss paper because those who are writing the next shifts know this data will be very useful for them. Okay, next after this, we'll go for the very important, this one. Numerical base, we know there will be 5 questions which are there, formula, substitute, and you have to end up with some answer. There is a numerical based. Ascension reason, 1 question. Sometimes they'll ask 2, sometimes they 1 year 1. Conceptual, what do you mean by conceptual? Something, no derivation, where you have to look at the analysis and you have to put, like this they've asked 2. Derivations, derivations means like where you have to, a situation is there and you have to derive the formula and one of the option will satisfy your derivation, like that. And as usual, objective numerical base 12. So your entire scoring of physics, this one and this one, because they are based on formula. Purely we do take up of formula here. They're based on formula. Similarly here also, and formula is needed. So your entire physics derivations means the physics scoring revolves around these 2 sections. So 12, 17, sometimes they go 19, sometimes they go for 18, 20 also they went. So therefore, all of you revise formulas. All who are writing that tomorrow, next shift, no, revise all the formulas, concepts, everything. There's a major section which will help you to get a best rank very easily. Don't bother conceptual, one, two questions are there. Assertion reason, one question only. Derivation type, maybe around two, three, four, or this paper five. But this is the major thing, no? So these two will is what rank decider. Everything for everyone who all want to qualify, who want 100 percentile. These two is what will help you a lot. Through formulas, solving will become easier. And that's what overall the physics paper appeared like this. I think the same strategy what they'll follow. So tomorrow when you go for it, maybe the derivations out of five, only three will come. This will be fixed. Okay, I agree this. This may be five. Instead of five, they'll go for three. This they'll increase. And the overall structure will remain same. Okay, kids. So this about the overall the strategies, everything, all writing for next shift. So we'll directly enter into the uh, paper solving. We'll see how the questions came, what will the approach, what we have to stress, everything. Have patience. I'll wind up in a less time. I'll explain clearly things. So let me start with this one. The first question. I'll take out the camera. It will be okay. The first question: an ideal solenoid is kept with its axis vertical. Current I naught is flowing in solenoid. A charge Q is thrown downward inside the solenoid. Its acceleration, the acceleration of the charge particle is A, then A equal to. What is this topic? This topic is based on solenoid. Where do it will come? Moving charges and magnetism. Question is moderate, not tough. Okay, fine. So what is the solenoid? Solenoid we can go for like this. This is a solenoid. Inside this, a charge particle will be projected. How the solenoid will produce magnetic field? If a current I is flowing, so let's assume that it will produce a magnetic field. There's a B bar due to flow of current I. Now there will be a charge particle. This charge particle we are going to throw it with a velocity V. So it's as good as like the magnetic field will be out of the plane. There's a magnetic field I'm showing. And there's a top view. From here, if you see it, no, the magnetic field is out of the plane. And the charge particle, how the charge particle, it is projected into the, this one, I can't show it here. It will be into the plane of paper. So directly we'll go for formula F equal to Q V bar cross B bar. Q V B sine theta. What is the angle between V bar and B bar? It can be here 180 or 0. Theta can be 0 or 180. This will become 0. Then what will happen to charge particle? The charge particle inside here will experience only mg. Then it will have acceleration A, where A equal to g. Agree this? A simple analysis is what you should do like this. Now let's come for next question. A wave propagates whose electric field is given by E equal to 69 omega t. Find the direction of the wave. In what direction the wave is propagating? along x-axis. The wave is propagating along x-axis. This is y, this will be z. And the E bar is directed along like this. I'll put it. This is a E bar vector. Definitely this should be B bar, no? How do you can say that one? E bar and B bar should be mutually perpendicular to direction in which the wave is propagating. What is C is equal to omega by K. So how do we can say direction of propagation is proportional to this one? Now we wanted C here. What we should do now? C bar cross E, C cap cross E cap will become direction of B cap. C cap is what? I cap. E cap is what? J cap. B cap. I cross J will be K. So therefore, it is propagating. Okay, fine now. Yes. This paper, this question come from topic EM waves and easier. Okay, next question. This, let me read this one. Two rods of equal length of 60 centimeter each are joined together end to end. Quotient of linear expansion of the rods are given this much. The temperatures are same and equal to 30 degrees, which is increased to 100 degrees Celsius. Find the length of the combination. Sum of the elongations. There's a one rod is there. This question is based on thermal physics. This question is based on thermal physics, and we can put it this question as moderate. Now, two rods are there connected end to end, each of length L. They're having alpha 1, alpha 2. Find the final length of the combination. Both the length will increase. Delta L is equal to delta L1 plus delta L2. Delta L1 will become L alpha 1 delta T, L alpha 2 delta T, L delta T alpha 1 plus alpha 2. Length is how much? 60 centimeter, which is rise to how much we are rising from 30 to 100. The change in temperature will be 70. Okay, fine. Afterwards, alpha 1, alpha 2. 24 into 10 to the power of minus 6 plus 1.2 into 10 to the power of 5. This will become how much? In terms of, or one more step, all right? Next, I'll simplify it. This will become 1.2 into 10 to the power of minus 5. Here calculations you have to be careful. 60 centimeters, so this will be 6 7 42, 4200, everything in centimeter. This will become 2.4 plus 1.2 into 10 to the power of minus 5. Okay, this will solve it. We'll get the answer. Calculations will be, we'll get the 3. Substitute and solve this one. We'll get the third one is answer. Okay, done. Next, we'll go for find the change in Find the change in intensity of gas if its temperature changes by 10 Kelvin. Number of moles of gas is 10. Specified constant pressure given value and universal gas constant. If temperature changes, this one, find the change. So what is asking now? Is asking about the number of moles of gas. So definitely the gas will. So this problem based on the thermal physics, and we can put category easy one. Then what is this one? Change in intensity of gas if temperature changes by, usually this is a gas, no? So we assume volume to be constant. That particular data should be given. Then isochoric process, the gas will undergo. Isochoric process. In isochoric process, what is Q equal to? Delta U, which is equal to NCV delta T. Number of moles 10. Cp, he has given Cp minus Cv equal to R. Per mole, he has given this one. So therefore, what we can write here now, we'll calculate the Cv value. Cv value, this will be 7 minus Cv 2, Cv equal to 5. Rise in temperature by 10 K. 10 Kelvin it is, not kilo. This will become 500 calories. This data was supposed to give this is not kilo, Kelvin it is. Okay kids, we'll take the next question. Let me read this one. Two mechanical waves on a string of equal length L, with tension T having linear mass density. He has given the ratio of linear mass densities, mass per unit length. Find the ratio of time taken for a wave pulse to travel from one end to other end, both the strings. There are two strings are there. There's a one string. This other one. And they are having the mu1, mu2. Same tension. Tension will be same. And a wave is set up. Here it will move with a speed v1. It is v2. It's asking the ratio of time taken for a wave pulse. Both are of length L. Then how to do this problem? We have to, what is this particular thing? Waves and sound chapter, and this will put moderate or easy also. So what is the v1? V1 equal to under root of T by mu1. V2 equal to under root of T by mu2. Is asking ratio of time taken. How you define v1? L by T1. L by T2. Is asking ratio of time taken from one end to other end. T1 by T2 I needed. T2 by T1, let me take it. So I should mu2 by mu1. Mu2 by mu1 will be root 2. T1 by T2 will be 1 by root 2. This is a key. Easily, I think, just substitution type. We take the next question. A satellite is revolving around a planet in orbit of radius 1.5 r, additional minimum energy required to transfer the satellite to new orbit of radius 3r. M is small m and m are the mass of satellite and the planet. And this problem based on the gravitation. So then additional minimum energy required. Change in energy. What is the expression for initial energy E1? Sorry, final energy minus initial energy. This will become GMM by in orbit of radius 1.5 r. Required to transfer to new orbit of radius 3r. Minus GM small m by 1.5 r. 1.5 you can write it as 3 by 2. So GM small m r, this will be 3 by 2. Sorry, minus 2 by 3. Calculations. This will become 2 by 3 minus 1 by 3. 3 2 just 6 will be final equation GMMR 6 minus, okay, this will be 1 by 3. Okay, fine. We are having let me check the calculation of 3 by 2. Okay, 2 by 3 minus 1 by 3. Lambda, this should be 3. Okay, fine. So this is about the gravitation chapter. Little bit we can put this easy one. Next problem based on mechanics. Springs 1. There are two springs or spring constant K1 and K2. If they are connected in parallel, then percentage error in equivalent spring constant of combination will be. What is this entire problem? You have to go for this is based on the spring series parallel. Now recollect the concepts of series parallel. Sir, what is the concept of series parallel? If springs are in series, if the springs are in parallel, I think we have the basic formula. Error analysis, we are doing problems on the based on the error analysis. Okay. I should solve or manageable. Errors. When you add errors, what will happen now? They are parallel. Parallel means they'll be connected like this. This based on the work energy power chapter. A little bit we'll call it as tougher. When the springs are parallel, K1, K2 blocks connected, then effective spring constant given by K1 plus K2. Okay, we are going to add up these two. K1 will be 20, then delta K, sorry, it will be like this. When you add two quantities, what will be the mean absolute errors are additive. Delta K1 plus or minus delta K2. If they are connected in parallel, percentage error in the equivalent spring. Delta K1 will be plus or minus 0.2 plus or minus 0.3. This will be plus or minus 0.4. What is the value of k equal to k1 plus k2? This is the mean value. This one will become mean value. This will become mean absolute error. Mean absolute errors are additive. Okay, k equal to k1 will be 20 plus 30. This will be 50. It's asking percentage error. Now what we do for that? Percentage error will be delta k by k. 0.5 by 50. 0.1. Multiply with 100. 1%. Okay, done. Next, this question is based on YDSC, wave optics. In a YDSC setup, a slab of width T is inserted in front of one of the slit. The interference pattern shifts by 0.2 cm on the screen. If the refractive index of slab is 1.5, then T is in n micrometer screen distance slit separation. This problem based on wave optics YDSC, and this will come under category of moderator. I'll show the derivation also. Very rare to ask with the slab. Okay, everyone, I have to pass this information. It's very rare they'll ask you about the YDSC with the slab. Only till now 5 questions. There's a 6 question. Now there's a slab. There's a slab of thickness T, refractive index mu, S1, S2. Let this be P, let this be Y. Now we have to calculate the path difference is equal to S2P minus S1P dash. This is equal to S2P. S1P dash will be S1P minus T plus mu T. Okay, sir, why you are writing in this way? In air, it will cover a path S2P in air. Okay, fine. The ray 2. Sir, what do you mean by ray 2? There's a ray 2, there's a ray 1. How the rays will go like this? Everyone able to imagine YDSC and this ray, or say wave, the wave 1, wave 2, they'll undergo superposition. Path difference will be there due to slab and also due to geometry. Now you can see this. This wave is covering a path S2P in air. This will cover a path S1P minus T. S1P minus T in air. In slab, T distance. Optical path length, mu T. This is a method. Okay, directly, I have to explain the concept. I can't directly, we can't write formula. This will become S2P minus S1P minus of mu minus 1 into T. This will be due to geometry, dy by capital D. We are searching for maxima and lambda. Y is equal to n lambda capital D by small d. This is what the shift. Interference pattern, how much it shifts by 0.2. This value is what? 0.2 meter. I'll write it here. This everything is S. So this S is equal to this S is 0.2 meter. Okay, done. Substituting all values. He has given the distance capital D, small d. He has given mu. He is asking to calculate the thickness. T. We'll get 8. Let me speed up. This half an hour got over. Now, next question is based on laws of motion. We'll put tough. A particle of mass 1 kg initially resting at origin starts moving under influence of a force F equal to 4t cube I cap 3t square j cap. If the speed of particle at t equal to 1 second is alpha, then value of alpha. Something it is directly based on the kinematics or laws of motion. F equal to 4t cube I cap minus 3t square j cap. M a bar mass 1 kg. So x component of acceleration will be 4t cube. Y component of acceleration will be 3t square. This will become dvx by dt. It is at 1 second is asking Vx zero to t. Vx equal to t to power of 4, 0 to 1. 4 will cancel out. Vy equal to this negative sign will be there. And this will be t cube 0 to 1. So this will become finally 1. Vy will be 1. Substituting upper and lower limit. What is v equal to? Vx square plus vy square. 1 square plus 1 square 1. Sorry, root 2. So root 2 means alpha will be 2. I'll take the next question. Next part is based on the question is based on the optical instrument. Focal length of objective lens and eyepiece are 1.25, 5 centimeter, and tube length. Find the magnification of component in normal adjustment. Normal adjustment is what we should do. We have the slide formula. Magnifying power is equal to L by F naught D by F. Normal adjustment means infinity it is. When final image at infinity, the lens will be like this. This is the objective lens. This will be eyepiece. Rough diagram. You keep object here, O. Then its image will be formed, I1, and the final image will be formed rough like this. Altogether, rays will become parallel. This eyepiece, FE, FO, and this is a length, where this UO will be very nearer. Will adjust like this. And this I1 will be very near to eyepiece, and the human eye will be located here like this. You'll be seeing here human eye. It should be human eye. Okay, sir, but what is this formula? This L is actually V naught. This U naught will become F naught. What is our actual formula? V naught, U naught, D by F. But usually this L will be made equal to V naught because this was the condition, the image, and this is the V naught value. This will become UV value. This will become V value. And this was the basic condition, no? I think he has given all the values. Length of the tube, L. This is L. This is F naught. This is F. Substitute all, will get this one. Instead of this is what we use in practically. Why we should go for this? Because we can't measure V naught. We can't measure this V naught. V naught is practically not possible to measure. This V naught, we can't measure this distance because we can't see I1. I1 is not visible. So how to calculate V naught now? So therefore, we are using this approximated formula. Okay, fine. And this based on optical instrument. The topic based on next we are having the alpha particle. It's based on the atomic physics, atoms, distance of closest approach concept. An alpha particle having kinetic energy 7.7 megaton is approaching a fixed gold nucleus atomic number. Find the distance of closest approach. You need not to bother anything very big concept. Here, this is the alpha particle. I'll project it. This is a gold nucleus. Oh. The initial separation is infinity. What is the distance of closest approach? Where it will come to instantaneous rest. It will undergo from here to here retardation because of repulsive force. So here we'll apply the conservation of mechanical energy. Initial kinetic energy plus interaction 0. Final kinetic energy 0. Interaction potential energy. Alpha particle. This will become Z E. Charge of alpha particle will be 2E by 4 pi epsilon naught x. This x is the distance of closest approach. But sir, how you do all this lot of calculations? As in fact, you have to fight with the calculations part here. How to manage calculation? Because on one side you are having the mega electron volt. Okay, this one 7.7 mega electron volt. This mega electron volt, what you can write? 10 to the power of 6 E equal to, this will be charge of the gold nucleus 79. This will be into 2 into E square 4 pi epsilon naught into x. So one E will cancel out. So 7.7 into 10 to the power of 6, 79 into 2. 1 by 4 pi epsilon naught will become 9 into 10 to the power of 9 by x. One electron will be left over. 1.6 into 10 to the power of minus 19. Solving all this, we'll get x in terms of 1.72 nanometer. Okay, everyone able to convert this mega electron volt? You have to convert like this, huh? Electron E, here E square and E is there. One square will cancel out. And 1 by 4 plus naught will be 9 into 10 to the power of 9. No, your answer will be this one. Let me take the next part. Find out work done in moving a 2 microcoulomb charge from A to B. There's a one charge fixed here. The question is, I think some data missing here. We have a charge which is fixed here. And other 2 microcoulomb charge no, this is some sorry for disturbance. Work done. Okay, will interaction potential you will calculate. This distance will be R1. Okay, fine. Work done by external agent is equal to UB minus UA. UA is what? They will call this as Q naught. Let this charge be Q. So this will become K Q naught by R1 K Q naught R2 K Q naught 1 by R2. K value will be 9 into 10 to the power of 9. Q value will be 10 to the power of minus. Q naught value will be 2 into 10 to the power of minus 6. What about other things? R1. How to calculate R1? R1 will be 2 square plus 1 square will be 3. R2 will be 4 square 25 plus 16 plus 8. 2 root 2, 4 to the 8. It will be 8, 16, 24 root 49. This will be 7. Substituting all solving, we'll get this answer. Let the calculation. So based on electrostatics. Next, a curve is given with potential energy of a particle and its a curve is given between potential energy of particle and its position on x-axis. Tan theta 1, the slopes are given. Force acting on the particles. This is, I think, purely conceptual. We have to directly go for the slope. The slope tan theta 2. And what is the formula? F is equal to minus du by dx. du by dx. So the force FBC. Slope will be positive, negative. This will become minus tan theta 2. FAB equal to minus du by dx. Tan theta 1. FCD will be 0 because slope is 0. FDE will be tan theta. Some issue is there. Minus 1 by 2. Minus of minus, this will be plus. Based on this, we can go for the magnitude. FBC, tan theta 2. Okay, this magnitude will be minus 3, minus 1, plus 1 by 2. Magnitude is asking FBC greater than FAB, greater than FDE, then greater than FCD. A simple conceptual base, this based on work, energy, power. A rod of mass m and length L is attached to two identical strings. Find the tension in the left string just after right string is cut. So here, initial tension how much? T naught, mg based on rotation motion. So this will become 2T naught equal to mg initially. So just after one of the string is cut. Tension mg. Okay, it will rotate about center of mass and center of mass accelerate. Then the formula will be mg minus t equal to mac t into L by 2 ml square by 12 into alpha c. And the acceleration of point P along y-axis should be 0. For this to happen, AC minus L by 2 alpha c should be equal to 0. So T is equal to M L alpha c by 6. L alpha c equal to 2 MAC. Then this MAC value I'll substitute. This will be 6. L alpha c, we are writing 2 AC. This part. Okay, fine. So MAC I can write it as T by 3. This value will substitute here. Mg minus T is equal to 3T. Okay, fine. Based on rotation motion, little bit tougher. This based on semiconductors. Which logic gate is given figure? This topic is based on semiconductor. Everyone's favorite compulsory semiconductor. Either they'll ask from diode or logic gates. Highest weightage. Prepare them. So here we'll start like this. This will be A, B, B complement, A complement, A complement, B complement, whole complement. Then C. The output like this. Here we assumed A. This will be a complement. Here B, B complement. Fine. Now A complement, B complement will become input here. And there's a NOR gate. A complement, B complement plus whole complement. Again NOR gate. So this value of C will be A complement, B complement, whole complement. So complement will cancel out. A complement, B complement. This will become AB whole complement. This will be NAND gate. You have to write Boolean expression based on dimension analysis. Based on dimension analysis. Now you're asking, find the dimensions of A and B. Where are A and B? A and B are here. So the dimensions of pressure. Pressure, what happens? The dimensions of pressure will be that of energy. We'll take help of dimension analysis. The dimensions of pressure will calculate. Pressure will be force per unit area. Force will be mass into area. M1, L1, T minus 2, L square. This will become dimensions of pressure. The dimensions of pressure should be the dimensions of A T square B. AB, dimensions of T square time. So dimensions of AB will be M1 L1 minus 1 T minus 4. Next question. This based on the current LCT. Find the heat produced in the external circuit. What is the external circuit? This one is the external circuit. External circuit AB. Here. That is everything we have to calculate the heat generated. Is it a Wheatstone network? Not Wheatstone network, because ratio of 1 by 2 is not equal to 2 by 1. So we can't remove this 1 ohm. So what to do for this? We'll go for a better approach. Here we'll call X, Y. Then we'll go for nodal analysis. Will be easier. From nodal analysis, X minus A by 1 plus X minus by 1 X minus B by 2. What is A? A in fact 9. This is 0. So in place of A, better we'll write 9. We can save time. And in place of B, the voltage will be 0. No? 9, this is 0, equal to 0. So this will become X plus X by 2 minus 9 minus Y. 5X by 2. Similarly, nodal analysis. Y minus 9 by 2. Y minus X by 1. Y minus 0 by 1. Here, nodal analysis. It will be like this. Y minus 9 by 2. Then Y minus X by 1. Nothing but KCL only applied there. Nodal analysis means. Then Y minus 0 by 1. So Y by 2, Y. So again, similar way, what do we get? We'll get 2Y, 5Y by 2 minus X minus 9 by 2. Solving these two, equation 1, equation 2. We'll get X and Y. After getting X and Y, we can work out all the things. We'll add up these two equations. 5x by 2 I'll multiply. This will become 25y by 4 minus 5x by 2 minus 45 by 4 equal to 0. Adding up these two, 25y by 4 minus y, 21y by 4, 5x by 2, 5x by 2, 5x by 2, 5x by 2, minus 5x by 2 plus 5 will cancel out. Will be left over with minus 45 by 4 and minus 9. Adding up these two, 4 also will cancel. So 21y is equal to 4 9s are 36. 36 plus 45, 81. This is the value of y. This value of y will substitute in x. We'll get the x. Then after getting this, we can calculate the current. Here I1, here I2, here I3, I4, I5. I'll add one page. Then afterwards what we do? We have to calculate I1. After getting y, substitute y in any one equation. Substituting this y in equation 1. 5x by 2 minus 9 minus 81 by 21 equal to 0. by 91. I'm using calculator. You cannot use calculator. 81 divided by 21. 3.86. Answer plus 9. 12.6. 12.9 divided by 2.5. 36 by 7. Then we can calculate I1, I2. What is I1? I1 will be nine minus x by 1. 9 minus 36 by 7. Okay, fine. Next I2. This one. I2 means this one. 9 minus y by 2. 9 minus 81 by 21 by 2. We'll call them as P, Q, R, S. What is I4? X minus 0 by 2. And I4, X minus 0, this one. So 36 by 2 will be 18. 18 by 7. I3 will be y minus 0 by 1. 81 by 20. 81 by 21, I think it will be 81 divided by 21. 60 it will come. Sorry, 81 divided by 21. 3.85. Or it will be 27 by 7. All the values will come like this. 27 by 7, like this you simplify. Then power we can calculate. Power will be I1 square into 1 PQ 2 ohm it will be. Lengthy, very lengthy 2 ohm it is. Q will be I4. Power in the Q will be R will be I2 square into 2. S will be I3 square into 1. Adding up all is total power. Solve the calculation. I don't have patience further. Okay, we'll take the next one. Air-filled capacitor of capacitance C is filled with dielectric with the width d by 3. Find the new capacitance. So this problem based on capacitor. Little bit moderate or simple formula based. Two capacitors, like we can assume like this. Dielectric width d by 3. This width will be how much? 2d by 3. And how they are parallel, no? They're series effective. 1 by c equal to 1 by c1 plus 1 by c2. C1 will be how much? This is C1. C1 will be epsilon naught A by 2d by 3. C2 will be K epsilon naught A by d by 3. C dash. What is C is equal to? F naught A by d. K equal to how much? 3. I think now we can solve this one. No? Nine epsilon naught A by 7 or 9C by 7. C is F naught A by D. This assumption is very important. Okay, effective capacitance is C dash. This based on the fluids. Bernoulli's theorem. Find the volume flow rate. Find the volume flow rate in the venturimeter given below, in which water is flowing. Here the liquid has rise to height 5 centimeters. Here this will be H1, this will be H2. The difference in what? 5 centimeters. Then pressure at A. What is the formula? Pressure at A plus kinetic energy at A is equal to pressure at B plus kinetic energy at B. Pressure at A minus pressure at B equal to KB minus K. Pressure difference is what? This H. This total, let it be HA, HB. So this will become rho G HAB. This will become rho VB square by 2, rho VA square by 2. Rho G, this will be 0.005 0.05 rho by 2 VB square minus VA square. Then you are going to apply the VA into area of cross section. A equal to A into VB. Capital A by A value given. (2.4). Okay, we'll get the density of the water given 1000. Substituting all these values, the rho will cancel out. Okay, this will be 10, 10, 0.5 equal to VB square minus VA square. This will become calculation. Here we have to work out calculations. This will be how much? This row will cancel out. This row and this row will cancel out. G, here 10 is there. 10 into 0.5 will be 0.5. 0.5 into 2 again will be 1. So what do we get? VB square equal to 1. Now you can find out either of one value. This will become 2.4 VA square minus VA square equal to 1. So this will become 1.4 VA is equal to 1 by root of 1.4. 1.4 we can approximate, right? 1 by root 2. Okay, we got VO. Now the flow rate will be Q equal to VA into A. I'll check the calculations once. Maybe some data I took wrong thing. It is like this. Okay, fine. Some data. Let me add some correction is there. Now it will be 3 will come, root 3. Squaring this 3 VA square VB square. VB square, this value will be VB square minus VA square equal to 1. VB square will become 3 VA square. A equal to 1 by root 2. It's asking to get the flow rate. No? VA I got it as 1 by root 2. Flow rate will be A into VA. We are getting this much. I think some data. I'm having this much of data issue is there. Further, I need value of A. I'll show the same data. That is the case, then this will become 2.4. Huge calculation. 2.4. Then 2.4 whole square will be this much. VB square will be, I think we'll end up here. Because some data we don't know from students we are gathering. VB square will become 2.4 square VA square. This will become 2.4 whole square. 5.76 minus 1 VA square equal to 1. 1 divided by 4.76 will be 0.2. Then this will become, flow rate will be A into VA will be 0.2 into root 3. Some data correction. Okay, fine. Let me go for in the electric field of EM wave, this is given. Photosensitive material having work function, find the maximum kinetic energy. I think from this we should calculate the sin C plus sin D formula. Two frequency components will come. And the one which is having maximum frequency, that has to be simplified. This question is based on the just a minute. I'll attend one call here. I'll continue. Okay, fine. So let's start this one. So we have the electric field vector like this. 60 sine 3 into 10 to the power of 40. We have to calculate sin C plus sin D formula. We had to add up omega. Omega will be sin C plus sin D formula. I'll go for trigonometry. Sin C, I've forgotten. Okay then. Sin C plus sin D, the expansion will be 60 will be as it is. 2 sine C plus D. 3 into 10 to the power of 14t plus 12 into 10 to the power of 14t by 2 cos of C minus D. 3 into 10 to the power of 14t minus 12 into 10 to the power of 14t whole divided by 2 into t. 120 it will become. This will become 15. Other quantity will be 994.5. So this will be 9 by 2. Two components are there. So this will become like 120. Which will be greater 15 by 2. So omega 1 equal to 15 by 2 into 10 to the power of 14. This will become 2 pi f1. F1 will become equal to 15 by 4 into 4 pi into 10 to the power of 14 Earths. Find the maximum kinetic energy. The maximum kinetic energy is given by K max equal to HF1 minus work function. H value also we have to substitute. 6.6 into 10 to the power of minus 34. I'll add one more paper. And this I'll substitute the value. 6 Planck's constant 34 into 15 by 4 pi minus work function. Work function is how much given? 2.8 electron volt. 2.8 into 1.6 into 10 to the power of minus 19. We have to express everything in electron volt only. So this E let's retain. Here we'll get one E and we have to solve it further. Now we'll verify. We'll get this one. Mega electron volt is telling. So 10 to the power of minus 20 will come. In the 10 to the power of minus 20 minus 19. So this will become 0.66 into 15 by 2 pi minus 2.8 into electron volt. Work out this one. I will take the next one. This again problem based on rotational motion. Find the moment of inertia of the system formed using two identical given axis rotation as shown. This axis of rotation into the plane. We'll do one thing. For our convenience, we'll assume like this. This x-axis, y-axis, above z-axis, IOZ is asking. There's a one rod, ml square by 3. About this will be ml square by 12 plus ml square. Moment of inertia for this rod. For this rod, it will be ml square by 3. For this rod, it will be ml square by 12 plus this ml square. Next, this problem based on electromagnetic induction. There is a plane conducting loop is there. Okay, fine. Now everywhere there's a magnetic field. It's having radius A. The magnetic field is B. The resistance of the loop is given R. And the magnetic field is varying harmonically. Average term dissipated in the loop in one period. First we'll calculate EMF induced flux equal to B into pi a square cos theta. B pi a square cos omega t. This will become B is how much? B naught. Some value needed, no? Okay, not there. 100t pi a square cos omega t. This omega is 100. Okay, wait. Something is on from my side. What is cos 0? Here B bar and A bar will assume in same direction. So cos 0, this will be 1. Pi a square will get it. This is a flux. This will differentiate equal to d phi by dt. This will become 100 pi a square cos 100t. Then power equal to E square by R. 100 pi a square. Resistance is how much? 100. Radius is area 1 meter. Directly this everything will become cos 100t. Then thermal energy dissipated. So how to calculate thermal energy? Thermal energy U equal to power into dt. Cos square. Cos square 100t dt 0 to t. The value of this will be 1 by 2 only will become. One period. What is the one period? We don't know one period. Omega is 100. 2 pi by t is 100. So t equal to 2 pi by 100. Pi by 50. Average power. Okay, this will become, the value will become, everything will be energy. This is average energy. This will become 1 by 2. 100 by 2. What is the average value of cos square function? 1 by 2. Tt get cancelled, so 100 will be there. 50 joules will come. Next one, again problem based on electromagnetic induction. Consider two smooth parallel conducting rails AB and CD bridged by a 10 ohm resistance. A conducting rod PQ length L is paired over two rails perpendicular to as shown. I'll draw it. There are two rails and they are connected by a resistance on it. Now we are going to place a conducting rail. Okay, I think till here okay, fine. This is 10 ohm. This is AB and this is CD and this is a rod. and this is moved with a constant speed v. This is a magnetic field. I think this is based on the electromagnetic induction. A little bit tough. So here the flux will be negative, and as you move the rod towards right, the area of cross section will increase, flux will increase. So negative flux increasing, d phi by dt will be negative. EMF induced positive. So induced current will flow like this. Then BIL force will act here. Then you have to apply equal and opposite force to maintain that constant velocity. So what is F external equal to BIL? I is equal to E by R. E equal to BLV by R. So B square L square V by R. If you know the formula directly, you can work out. Otherwise, you have to derive this much. Motion EMF concept. Next, we are having consider a system of two coaxial convex lens L1 L2 having focal length f1 and f2 respectively. Parallel beam of light having is incident on L1 and emerges at parallel beam of diameter after reflection through. Find the focal length of lens L2. There are two lenses are there. I think problem little bit assumption of diagram very important. There's a one lens. Then there is another lens. Focal length f1. A parallel beam of light having diameter is incident here and it will become 7 millimeter diameter. Next we are having it will become broader, no? Merges out of parallel beam of diameter after reflection. Find the focal length of lens L2. I think some separation between the lenses needed. Some data. The rays will converge here. The rays will try to converge here, no? Before this lens, they'll try to converge. We'll bring like this. Then this will become virtual object. Virtual object at the first focus. Image will be at infinity. Oh. Coaxial convex lens. Some issue with the diagram. I am not getting the diagram properly. Let me check my data. Two convex lens changing diameter of the beam. And there's an issue with the question. Whether this question is there or not, I'm not sure. But one should be concave lens. Both cannot be convex lens. I think convex lens. Coaxial convex lenses. One should be convex, other should be concave. Okay, fine. Here, I'll do like this. They will come here. Then I'm trying okay, this will be okay, fine, yeah. It'll be like this. There's a ray 1, there's a ray 2. For this is F1, this is F2, diameter D1, this is D2. I got the data now. So this will be theta. This will be theta. Tan theta equal to D1 by 2 by F1 F2 by F1 equal to D2 by D1. F2 equal to D2 by D1 into F1. Okay, fine. We have given values. They could have given diagram. A little bit tougher. Ray optics. Last question I'll end up. Very lengthy. I think I explained a lot. During transition of electron in an helium atom from orbit 3 to T, the wavelength of the photon released is equal to wavelength of the photon which is released in the transition from 2 to 1 in hydrogen atom. When an hydrogen molecule dissociates into respective energy is released. Okay, statement 1 is correct. Helium atom 3 to 2. Helium atom 3 to 2. Energy will be helium plus Z square 13.6 electron volt 2 square 3 square minus 13.6 electron volt, 2 square, 54.4 electron volt, 1 by 4, 9 minus 4 by 36. So this will become 5. 54.4 electron volt, 5 by 36 is equal to wavelength of photon, which is in the transition from 2 to 1 in hydrogen atom. Wrong statement. This will be false. This will be true. Statement 1 is incorrect, but 2 is correct. Okay, fine. So this is about the overall our paper discussion. I think I took a lot of explanation I made here. That's why paper has become lengthy. Otherwise, okay, fine, manageable. Okay, thank you all of you kids. Second shift shortly I'll upload it. Okay, thanks for your cooperation. Thanks for great support. All the best. Those who are writing the exam 22, 23, 24, 28, all the best.